Let me tell you about an alternative notation that exists for the integrals that look like this. f.dr. Okay, so sometimes these integrals are written in a different way. So let me justify to you what that way is. The key is that we can write the integrand as f.dr. If we now substitute the definition of dr here, we have f dot dr is the derivative of r with respect to the parameter u times du, where, if you remember, this is just doing the derivative with respect to u of the function r of u, which is the parametrized curve, which can be written as x of u, y of u, and z of u times du, which then we can write as, this is f dot a vector that would be dx over du, dy over du, and dz over du times du. And actually, if we now group, so if we now bring this du inside of the vector, it will cancel out with the du's here. So you would end up with f dot dx, dy, dz. When I was preparing to record this video, I first wanted to directly go from here to here by saying that dr vector can be written as dx, dy, dz. But then I thought that some of you might be confused by this. So just to clarify that you can do that safely, okay? So this just means that x, y, and z are three functions of the parameter u because they represent the curve. So x, y, and z depend on the parameter u. So you can calculate the differentials of x, y, z, which are the differentials of functions, okay? So of course it makes perfect intuitive sense that dr vector is just a vector made up of dx, dy, and dz. So now we can actually carry out the dot product. So maybe we expand f into rectangular basis. So it has an x component, a y component, and a z component. And we are doing the dot product with dx, dy, dz. So if we do this dot product, we end up with a scalar which is fx times dx plus fy times dy plus fz times dz. Okay, and that's the alternative way of writing the integral. So sometimes the integral is written as the integral of some function dx plus some function dy plus some function dz. Okay, and in general, fx, fy, and fz may be functions of xyz in the most general case. So if you ever see a problem asking you to calculate something like this, okay, maybe it looks like this: calculate the integral on some curve c, which it would define, of 1 plus x dx plus x times y dy plus 0 dz. Maybe it asks for this, and you would be a bit surprised of why do I have two differentials? Well, actually, this is everything that this is saying is that f is equal to 1 plus x as the x component, x times y as the y component, and 0 as the z component. So it's asking you to calculate f dot dr for this function here. Okay? So don't be scared if you see a problem asking you something like that. Excellent. Let's see an example of that, an actual problem with this example in the next video. See you.